Hey everyone, welcome back to the channel Code with AKJ. Today is day 34 of solving LeetCode 75 challenge series, and today we'll be solving another problem from binary tree DFS, that is leaf similar trees. So if you're new to the channel, make sure you hit that subscribe button and hit that bell icon so that you never miss an update from this channel. So let's get started with our problem statement. So the problem statement says, consider all the leaves of a binary tree from left to right order. The values of those leaves form a leaf value sequence. For example, in the given tree above, the leaf value sequence is 6, 7, 4, 9, 8. So two binary trees are considered leaf similar trees if their leaf value sequence is the same. So return true if and only if two given trees with head nodes root 1 and root 2 are leaf similar. So the problem states that we are given two binary trees and we need to check if their leaf value sequence is the same. The leaf value sequence consists of values of leaf nodes from left to right. So for example, I've written two binary trees here. The leaf sequence of this given binary tree is 6, 7, 4, 9, 8, whereas the leaf sequence of this binary tree is 6, 7, 4, 9, 8. That is from left to right, from left to right. So based on the sequence of these two binary tree leaf nodes, we can say that these two trees are leaf similar trees. So now since we have understood our problem statement, so let's try to solve it. So our approach here would be to perform a DFS traversal on both the trees. We will collect all the leaf node values in two different lists, and finally we'll compare these two lists whether they are equal or not. So it's a pretty straightforward approach. So let's try to understand how DFS traversal works on these two trees and how we are going to collect the leaf nodes in two different vector and we'll compare them. So let's try to dry run using this given example. So we'll perform DFS on this given tree, tree 1, and in this given tree, tree 2. So in our DFS traversal, we'll first check whether the current node is a leaf node or not. So a leaf node is a node whose left child and right child are null. So here, since the current node is 3 and the left child and right child are not null, so we'll give a left call to this current node. So again, we'll check whether the current node is leaf node or not. So since the left child and right child of this current node 5 are not null, so we'll again give a left call. So we'll again check whether the current node is a leaf node or not. So since their left and right child are null, we have found our leaf node and we'll push this current root value into our list, that is 6. Again, we'll give a right call from 5 and we'll check whether the root is a leaf node or not. Since it is not a root node, we'll again give a left call, and since 7 is a leaf node, as their left child and right child are null, we'll store this value, that is 7. Again, 2 gives a right call, and since 4 is a leaf node, we'll store this value into our list. And finally, 3 gives a right call to 1, 1 gives a right call to 9, and since 9 is a leaf node whose left and right child are null, we'll store the 9 value into our list. And 1 gives a right call to 8, since 8 is a leaf node, we'll store 8 value into our list. So in this way, we have performed a DFS traversal in our tree 1, and finally we have stored all the leaf nodes in the order from left to right. Same goes with the tree 2. So 3 gives a left call to 5, 5 gives a left call to 6. Since 6 is a leaf node, we'll store 6 into our list. Again, 5 gives a right call. Since 7 is a leaf node, we'll store 7. Again, 3 gives a right call to 1, 1 gives a left call to 4. Since 4 is a leaf node, we'll store 4. And finally, 1 gives a right call to 2, 2 gives a left call to 9. Since 9 is a leaf node, we'll store 9. And 2 gives a right call to 8. Since 8 is a leaf node, we'll store 8. So in the same way, we have performed the DFS traversal on this tree too, from order left to right. So since we have stored the leaf nodes of both the trees in two different lists, now we'll try to compare these two lists whether they are same or not. As we can observe, the values of these two vectors are same. We can say that these two trees, that is T1 and T2, are leaf similar trees. So the time complexity of this approach is O of N1 plus N2, where N1 and N2 are the number of nodes present in given tree 1 and tree 2. Whereas coming to the space complexity, the space complexity is O of L1 plus L2, where L1 and L2 are the number of leaf nodes present in tree 1 and tree 2. So this solution is quite optimal. So let's code this approach and let's submit. So let's quickly code our approach. Our base case would be if any of the root value are null, that is if root 1 is null or if root 2 is null, will return false. So we'll take two vectors, leaf 1 values, leaf 2 values. We'll call DFS on both the trees, that is root 1, and we'll send the leaf 1 vector. We'll again call it DFS and we'll send root 2 and leaf 2 vector, and finally we'll check whether these two vectors matches or not. So based on this condition, it will either return true or false. So let's quickly code our DFS function. So it takes root value and it takes a vector. So here in our DFS call, the base function would be if root is null, will return. And here our first step here would be to check whether the current node is a leaf node or not, which means if root left value is null and root right value is also null. So in this case, we'll push this current node value into our vector. And finally, we'll send left call and right call, sending root right and vector. So this would be our code for our approach where we have used depth first search on both the trees. We have stored the leaf node values in two different lists or two different vector, and finally we have compared both the vectors, and based on this particular condition we'll either get true or false. So let's quickly run this code. It's working, so let's submit. As you can see, this approach gives a successful submission. So the time complexity of our approach would be O of n1 plus n2, where n1 and n2 are the number of nodes present in both the trees, tree 1 and tree 2. Whereas space complexity contains O of L1 plus L2, where we have used two different vectors, which contains number of leaf nodes present in both the trees, tree 1 and tree 2. So if you found this explanation helpful, make sure to subscribe to the channel and hit the notification bell so you don't miss any updates. So that's it for today's problem. We have solved this leaf similar tree problem using DFS approach. So I hope this was helpful. So if you have any questions or suggestions, drop them in the comments below. Don't forget to like, share and subscribe for more such content. I'll see you in the next video. Thank you.